Hello, investors. Today, we are discussing the biggest paradigm shift in the semiconductor industry in decades. It is the transition from electricity to light, the silicon photonics revolution. NVIDIA's next-gen GPUs, Broadcom's latest switches, and NTT's ambitious ion vision. The keyword connecting them all is co-packaged optics, or CPO. Why light now? Who will dominate this new era? By the end of this video, you will understand the investment strategy for the coming age of light, the physical limit of copper. First, let's understand the fundamental reason why. The entire industry is shifting towards light. The answer is simple. We have hit the physical limit of traditional copper wires, known as the heat wall. Did you know how much power modern data centers consume? Surprisingly, it is estimated that about 40% of that power is not used for computing itself, but for cooling the servers. When electrical signals travel through copper wires, resistance creates massive amounts of heat. As chips get more powerful and wires get thinner, this heat problem exponentially worsens. For example, NVIDIA's next generation Rubin NVL72 rack system is projected to consume a staggering 120 kilowatts per rack. At this energy density, traditional air cooling is no longer sufficient, and transmitting signals via copper wires becomes physically unsustainable. Therefore, the transition to light, which generates almost no heat and travels at light speed, has become a physical necessity. What is CPO? Co-packaged optics CPO has emerged as the game changer. To solve this heat problem, CPO fundamentally changes the architecture of the data center. In traditional data centers, optical transceivers, known as pluggable modules, were plugged in far away from chips like switches. Signals still had to travel via electricity from the chip to the module, causing significant power loss and signal degradation along the way. CPO is different. With CPO, the optical engine, which converts electrical signals into optical signals, is integrated right inside the same package as the ASIC chip, placed immediately next to it. This minimizes the distance the electrical signal needs to travel. As a result, CPO is expected to reduce power consumption by more than 30% to 50% compared to traditional pluggable methods. Furthermore, once converted to light signals, data can be transmitted over virtually infinite distances without worrying about signal degradation. The market leader, Broadcom. So who is currently leading this CPO market? The undisputed king right now is Broadcom. They were among the first to commercialize CPO technology and are already in mass production. Their flagship product is Bailey, the industry's first 51.2 Tbps CPO Ethernet switch. This product integrates Broadcom's latest Tomahawk 5 switch chip with their optical engines into a single package. Broadcom's strength lies in its vertical integration. They own everything from the switch, chip design to the laser sources needed for the optical engine, and the packaging technology to integrate them. Bailey is already being deployed in cutting-edge data centers of hyperscalers, powering AI infrastructures like Google's TPU clusters, becoming the de facto standard for the AI network backbone. The challenger, NVIDIA. Meanwhile, NVIDIA, the king of AI, is also steadily preparing for this optical revolution. Currently, NVIDIA's GPU interconnect technology, NVLink, mainly uses copper wires. Even in their latest GB200 NVL72 rack, a massive copper backplane is used to connect GPUs. However, NVIDIA's roadmap is clear. Starting with the next-generation Rubin architecture, they plan to introduce optical technology, or optical interconnects, for connections between GPUs. This means bringing optical fibers right up to the GPU chip and handling communication between chips using light. CEO Jensen Huang's ultimate vision for the AI factory is for the entire rack, and eventually the entire data center, to become one massive computing system, connected at the speed of light. NVIDIA is aiming to lead the transition to light in the compute domain as well. Japan's ambition, ION. As the world moves towards light, Japan is also proposing a grand national-level project, the ION vision, led by NTT. ION stands for Innovative Optical and Wireless Network. It's an ambitious vision to connect everything from network infrastructure to end devices with light. The core of this vision is the All Photonics Network, APN. The target numbers set by the ION vision are simply staggering. Compared to current networks, it aims to increase power efficiency by 100 times, expand transmission capacity by 125 times, and reduce end-to-end latency to 1200th. To achieve this, NTT is collaborating with global giants like Intel and Sony, accelerating the development of photoelectric fusion devices. The first commercial services are scheduled to begin between 2025 and 2026, holding the potential for Japanese technology to once again support global infrastructure. The brains, Europe. The technological innovation in silicon photonics is actually supported by the brains of Europe. In particular, IMEC, a research institute located in Belgium, functions as a global R&D hub in this field. IMEC leads the world in basic research on silicon photonics, manufacturing processes and device design. The technology platforms they have developed have become the de facto standards for many foundries and device makers. Also, institutions like Ghent University, also in Belgium, are producing world-class research results in the field of optical chip design. While Europe may lack large-scale manufacturing bases, it holds the key to the future of silicon photonics through standardization and crucial intellectual property, IP, occupying a vital position in the ecosystem. The factory, TSMC. And it is TSMC, the world's largest foundry in Taiwan, that turns these cutting-edge technologies into tangible products. TSMC has developed a proprietary, advanced packaging technology for silicon photonics called CPO. CPO stands for Compact Universal Photonic Engine. It uses 3D stacking technology to integrate the EIC chip, which processes electrical signals, and the PIC chip, which processes optical signals, into a single package. This minimizes the connection distance between the electrical and optical chips, reducing signal loss to the absolute limit. Based on this CPO technology, TSMC is building a powerful design ecosystem in cooperation with EDA tool, vendors like Ansys and Synopsys, aiming to establish a dominant position in optical chip manufacturing for the AI era, the supply chain. Finally, let's talk about the hidden winners in the optical ecosystem that investors cannot ignore. The widespread adoption of silicon photonics will create new booming demand in the supply chain. First, pay attention to test equipment manufacturers. Optical signals are harder to test than electrical signals and require advanced measurement technology. Companies like Keysight Technologies and Japan's Anritsu play important roles here. Next are connectors and materials. The demand for ultra-precise optical connectors to connect chips and fibers, special lenses to bend and focus light, and the optical fibers themselves will explode. Here, the technical prowess of Japanese companies like Sumitomo, Electric, and Senko. Advanced components is highly regarded globally. Also, companies like Shin-Etsu Chemical and Furukawa Electric, which provide silicon wafers for optical chips and special compound semiconductor materials, will be important players providing the picks and shovels in this gold rush. Conclusion. In conclusion, we are standing at a historic turning point for semiconductors. The transition from copper to light is now an inevitable future. As an investment strategy, it is important to understand the timeline of this transition. We are currently in Phase 1, where the introduction of CPO is progressing, in the field of network switches led by Broadcom. Then, from 2026 to 2027, we will move to Phase 2, where optical technology will begin to enter the compute domain in earnest, starting with NVIDIA's GPUs. It is time for investors to shift their funds from stocks related to traditional copper wires and air cooling to silicon photonics, CPO, and the specialized light companies that support that supply chain. Catching this paradigm shift early and investing in the winners of the next era will be the key to semiconductor investment going forward. Thank you.